Welcome back to the Android Development Series 2025. Today, we're exploring ComposeNotes, a powerful note-taking app built with Jetpack Compose. I'll walk you through its core features and then dive into the code to show you how it all works under the hood. So, without further ado, let's begin exploring this app. So you can create a note for your homework. Write an essay. Any essay, okay, and hit save, and here's a note. You can edit the note as you like. Maths exercises 2. You can change the title if you want. Today's homework. Yeah. And you can lock your note if you want, like passwords maybe, any password. This note will require PIN to access, and it's locked. To unlock it, you can. There's a hard-coded PIN right now, but we're gonna implement a better security feature later. And that's it. But what if you try to save the note when it's locked? What exactly are you trying to save? And what if you try to delete this note? Nice try, dweeb. Unlock it first. Yeah. And that's about it. But you can see the about section of this app. The search is to be implemented later. And this app is going to function as a to-do app too later on. Coming soon. Okay, that's about it. Let's get started with our project. Now, first I want you to create a new project with the name ComposeNotes and Android SDK 11, and then come to App, Kotlin plus Java, ComposeNotes, the directory, and main activity. And then delete these composables and this. Let's start by defining our dependencies. So in build.gradle.kts for the app, come to plugins and insert this ID Kotlin.capt, and then in dependencies write these three: implementation, capt, and another implementation. These are basically the room Kotlin script and room compiler and the room runtime for the room database. Now let's define the nodes. The entity for the node, the table for the nodes. So the table for the nodes will have a title, content, a timestamp, and the logged boolean is logged boolean. So the timestamp is required to sort the nodes in the recent manner. And the logged boolean would of course help us log the node. Now the nodes would also have a primary key which would be generated automatically, and will have an integer ID. So the primary key is basically an attribute that differentiates different rows in a table. It's how you identify a row uniquely from others. Now let's define a data access object which would be required to access these nodes, which would be required to manipulate the table, like insert a new node, update a node, or delete a node, and also get all the nodes. So these suspend functions here, they would make sure that the program runs without stopping the execution, while the suspend function fetches the nodes and also updates it without, halting everything for the program. And we have insert, update, delete, and get all nodes. So you see that it's a flow list. It's a flow list. That means the nodes would be returned asynchronously, and again, without stopping the basic flow of the program. Now let's look at the nodes database, how to create the database actually. So that was data access object, DAO. Data access object, which would help us access the data. And the database. Now let's create the database. So the database has the nodes class. Its version is 1, which means it's the first version of this database, and later we can change this version and migrate to another database. And export schema is false, which means we don't need to export this to the file manager. Now let's look at how it's implemented. So the abstract class nodes database would be a child of the room database class. And we define a node DAO, which is basically the nodes database object, and a companion object which would have an instance, and it's volatile, which means it would be accessible to the entirety of the program. And now let's look at the get database function, which returns the nodes database. And the instance is returned synchronously, and the instance, to create the instance we would use this code: room.databaseBuilder, context is application context, nodes database is a class, a Java class, and the name of the database is nodesDB. So we're going to build it, and we're going to set the instance variable to the instance that we created. This one, this variable, this constant variable, and we're going to return it. If this is complicated for you for now, you can just code it and try to understand it later. And I'm also going to upload a new video where I'm going to explain abstract class and object-oriented and functional programming. Now let's look at the nodes repository. So a repository is a design pattern that acts as a mediator between your app's data sources like room, network APIs, or files and the rest of your app, especially your view models and UI. So it basically acts as a mediator between your app's data sources. So here it's going to manage the node data access object, so you don't have to interact with the data access object directly. It's another layer above the data access object to manage the database. So we're going to define a class and an attribute node DAO, data access object, to actually take it from the outside, and all the nodes can be accessed using the node DAO getAllNodes function. And again, we have a suspend function for insert, update, and delete. This code is very simple. You just have to put the attribute as node, argument as node, and just node DAO.update, delete, and insert, which was defined here in node DAO. So that's basically it for defining the database. Now let's look at how to make the view model for this app. So a view model is a lifecycle aware component that stores and manages UI related data for an app screen. It survives configuration changes like screen rotations and separates business logic from UI logic, making your app more modular, testable, and resilient. So the nodes view model would have a repository, nodes repository, and a view model as its parent class. And it's going to fetch the nodes, it's going to add a node, delete a node, update a node. It's basically going to access the repository and insert, delete, and update the nodes. And our nodes view model factory would create the view model factory. It would create the nodes view model, and it has a function create. In case it fails to create the repository, it's going to throw an illegal argument exception, unknown viewModel class, and that's about it. Now let's get to the exciting part, the UI and the navigation of this app. Now let's look at our navigation. So in navigation package, in AppNavHost, we defined a seal class. Seal classes let us define a closed set of possible states or outcomes. The compiler knows all the possibilities, which helps us write safer code with exhaustive when expressions. So here we define the nodes screen, the add node screen, the nodes detail screen, and the to-do screen. So It's defining all of our screens at one place. It's for the app nav host. So you can know the ID for the composable. Now in this fun function app nav host, you have a nav controller, the nodes, on add node function, on delete node, on update node, and the modifier. So you define the nav host and give it the nav controller, and we start the app on the screen nodes, on the nodes screen, using screen.nodes.route, which gives us nodes, the home screen. So it's going to start at the home screen, and the composable for the node screen is defined here with the node screen composable, and we define the add node composable route using add node screen on save node, and also we define the nodes detail route, and the arguments would be the node ID, which is integer type. So we get the node ID, and we're going to find the node by checking its ID. If the node is not null, we're going to call the node's detailed screen, and it's going to pass the node, and on back we're going to pop the stack and come back to the home screen. On delete, we're going to delete the node and pop the stack again, so we come back to the home screen. And same with the on save, we're going to update the node and we're going to pop back stack. Otherwise we're going to show node not found. Also, we're going to have this composable as a route for navigating through the app. We're going to have this to-do app route, which can open the to-do screen composable. So in the to-do screen composable, we have a column which stacks things vertically, and we have an icon, the hourglass top icon, and a description, to do, and the modifier will define its size, which is 60 density pixels, dp. Spacer, so we have some space between the icon and the text, coming soon. So that's the basic layout for the to-do screen, which we're going to implement in the later video. So that's basically it for our app navigation host. Also, don't forget to add this dependency so that you can access those icons. Let's look at the final piece of this puzzle. So that's going to be the UI. So the Notes screen inside the Notes UI package is the home screen for our app. And we have a show about dialog, which will trigger our alert dialog about app. ComposeNotes, developed by me, the Gen Z dev. And you have this on dismiss request, which is going to make it disappear, and the confirm button would do the same, and it's going to have the text OK on the button. Now let's look at our scaffold, in which we will have our nodes. So if the nodes are empty, it's going to show an animated empty state, and it's going to show a lazy vertical grid with 2 columns. It's going to fill the maximum size of the screen and the padding values must be the same as mine. So the vertical arrangement will also have some padding spaced by. The cards would be spaced by 8 dp and aligned to the top vertically. Horizontally they would be spaced by 8 dp. And the items function would take nodes as its items, and for each node it's going to render a node card, which we define in components. So that's your node screen app, and now let's look at components. So the components would be used by both the add node screen and nodes detail screen, or the node detail screen. So it has the nodes top bar, on search click and on menu click are its arguments, expanded by, remember, mutable state of false, and the top app bar, whose text is ComposeNotes is the title, and we define the actions or the buttons. So the icon button for the search, which hasn't been implemented yet, can be displayed like this, and that 3-dot button can be displayed by icons.default.moreword. And then we have the drop down menu, which is defined like this: expanded equals expanded, from here expanded, and we have the drop down menu item, settings, and about. Make sure the window insets is set to status bars, or it's gonna do some crazy stuff like create a gap between your notification bar and your app, and your top app bar where you show the ComposeNotes title. Now let's look at the node card. So we define the node card as a column. Inside it we have a row, a spacer, and different configurations for if the node is locked or if it's not. So first we have the row, which shows the title and the icon for the lock, and we have the spacer, and we have this node is locked. If the node isn't locked, we're going to show the first 50 characters of our content of the node, and if it is locked, then the access is restricted, and yeah, max lines can be 0 or 1. Yes, max line should be 1 because it's just one line, right? So let's look at the lock toggle now, and we're going to use this in add node screen right here. So let's discuss this. So it's a row, which means it's gonna stack the elements horizontally. And first we have this lock this node text, then we have the switch, for which we defined the checked would be is locked, and unchecked change. We're gonna call the function on toggle, but here it's the parameter for it. We're going to define the function later right here on toggle, as you can see. And then we have this animated visibility, which will show this text in an animated manner. Finally, we have this animated empty state and the bottom nav bar. So in the animated empty state, you have this column which has this animation called scale, and you have this icon which would be animated, and the spacer and the text. Like you saw in the intro screen, you had this icon shrinking and expanding. That's this animation, and you can apply it using graphics layer, scale x equals scale, scale y equals scale, and yeah, scale x would use this animation that we defined here, scale, and scale y would use that same animation. And the spacer, and finally the text, and no notes yet, tab plus to add one. So that's your animated empty state. Now we look at the bottom nav bar. So we have the nav controller passed to it, and we have the items, notes, and to do, and the nav backstack entry by nav controller.current backstack entry as state. It's gonna save the backstack entry, which is basically the previous screen that was open, and we're gonna use it to define the current route. And then we're gonna define the navigation bar with maximum width, and for each screen we're gonna define the item and highlight the selected, and on click we're gonna navigate using the nav controller that was passed, and we're gonna pop up to nodes, screen routes, save state true. So it's gonna save the state, save the configuration, and it's gonna navigate there. And the restore state is true, so that when we're going back to it, the state would be restored. And icons can be defined like this using a when statement. So when screen is notes, the image vector is this. To do, then it's a list icon, and the labels. We're gonna set the labels. If notes, notes. If to do. Else, nothing. Okay, that's your bottom nav bar. Now let's look at add note screen. So this is fairly simple, and it's gonna have an own save note and an own back parameter. Both are functions. One takes note, other takes nothing. So in add note screen you have the title, the content, the isLogged switch that you saw before, and we have the top app bar again, but this is custom defined. We don't use the one in components, which was this, which was nodes top bar. It's a new one, so it has no title. The navigation icon is an on back icon, arrow back, and the action, we have icon button on click, the save button, that's what we have here. And if title is in blank and if content is in blank, we're gonna save successfully. We're gonna create a new note with title, with content, and with isLogged, and we're gonna save the note using onSaveNote function, new note, this one. And we have the padding for the scaffold. Inside it we have a column that you saw before. So it's an outlined text field with title. On value change, it's going to change to whatever you type, and the placeholder for it is title. And the colors are transparent: focused border color, unfocused border color, disabled, error border, focused container, unfocused container color. All are transparent. And then we have a spacer and the content. The same stuff as this, but now we have the value equals content, which is your note. So its placeholder is write your note, and the modifier fields max width. Maximum lines are undefined. It's just maximum value, so you can type a message as long as you want. And we have a spacer again, and the lock toggle that you saw in components. We're using it here. So all these composables in this components file, we're going to use it in add notes screen, in notes detail screen. So this is the final file. So in this file we have this pin unlock dialog, which is a cheap security measure for securing your notes, but we're going to define a better one in the later videos. So we have this notes detail screen, and it takes a note on back, on delete, on save. And we have the unlocked, title, content, context, and show pin dialog variables. So each has its own use. So first we have the top app bar. First we have the scaffold, and inside the scaffold we have the column. And yeah, that's the column. That's where your content would be visible for the note. So it has this top app bar, which would have no title, and the navigation icon would be the arrow back. And when you save the note, it's going to delay for 800 milliseconds so that the Compose gets enough time to save your notes, to process it through the database. And then it's going to call the onBack function. Next we define the scope, which is this right here, icon button, which is the on save button. Yeah, it's the save button, default.check. So if you press arrow back, it's going to save your note, and if you click the save button, it's also going to save your note. Yeah, that's the basic architecture. And then we have the delete button, which would check if the note is unlocked, and it's going to delete it, or it's going to show this: nice try, Dweeb, unlock it first. And the window in sets would be status bars, because you want the top app bar to be at the top and not leave some awkward space between a notification bar and the bottom. So we have the column and the modifier. We need the vertical scroll. Remember scroll state, fill max size for the column. And this column would be where you will see your note. And if the note is locked and it's not unlocked, then we're going to display this. So it's a column with an icon, a spacer, a text, and a spacer and a button. So let me explain what it is. You have an icon, lock, then you have some space, and then you have some text. This note is locked, tap to unlock. And then you have another space, and then you have a button, unlock. Otherwise, in the case that the note is not locked, it's going to show this, a horizontal divider after the top bar, and you're going to see an outline text field for which the outline is transparent. Yeah, it's a sneaky detail. The title is actually an outlined text field, but you don't see it because it's transparent. And then you have a spacer just to put space between the title and the content. And then you have the content with the placeholder, write your note, and the content. You have the max lines defined here, which would be a very, very big value. And the colors are transparent again. You need outline text fields defaults object to use them to define these colors. And finally, you have the show pin dialog. Okay, so let's discuss pin unlock dialog composable, which is right here. So it takes on unlock, on dismiss. It takes a pin input, which is nothing. And right here you can type out your own pin, like 6999 or maybe 6666. And then we have this alert dialog that you see where you can enter your note. On dismiss it's going to close. On confirm it's going to ask for the pin, and it's going to compare the pin to the correct pin, and then it's going to, and then you have this unlock text as the confirm button. And if you dismiss, if you cancel it, it's going to get dismissed and it's going to close. And the title is enter pin for this outlined text field. No, for this alert dialog the title is enter pin, and we have an outline text field where you can enter your pin, and the keyboard opens up and you type it out, and it's going to be a single line one. Yep. Value would be pin input. On value change it's going to change it to the value you type. Okay, enough. And now we're going to see how to call it. Pin unlock dialog. Unlock, it's going to change the unlocked variable to true. Show pin dialog to false because it's going to close the dialog. And on dismiss it's going to do the same. So if you tap outside the alert dialog, it's going to close. So that's your app. And that's almost all of it. So this project took me about 10 hours to implement. Make sure you like and subscribe to the channel, and stay tuned for more videos like this. And of course, the second part of this video, where we're going to build a to-do app inside this app.